the domain. Absolutely. Good. What else? After we find the domain, what else are we definitely looking for if they exist?
X or Y intercept?
Yes. We have to look for the x-intercept, y-intercept. So this can only be one, because if a function crosses the y-axis more than once, it's not a function. But the x-intercepts may be one or more, but the y cannot be more than one. Okay, then what is the mandatory step? After domain, I will help you with this one, the table of ordered pairs. I want to establish this now because this is important for chapter 4 that we have to start on Thursday. Okay, so these are the mandatory. I can add number 4, which I will discuss. It's called symmetry. So we have not discussed this. You did in pre-calculus, but it doesn't matter. I will review it from scratch. I will present it from scratch, and I'll explain what it means. It is a very important concept. So at least these 4, okay, we should know before we get to chapter 4. We should remember. But again, I will present this. Even I know it was presented in pre-calculus. I present it all the time in pre-calculus and college algebra. But we haven't discussed it this semester, so I'm not going to discuss it right now. Okay, what is the rule? I'm losing my voice. What is the rule of finding the derivative of natural log raised to tangent? What do I write here?
Chain rule.
Anyone else?
Power rule.
Okay, anyone else? So we heard chain. We heard power. Anyone else? No other bidders?
Is it a formula?
There is no rule, but it is a
two-step procedure.
Thank you. Thank you. It is a 2-step procedure. Okay, awesome. Thank you very much. 2-step procedure. I should have written this as 2-step, whichever you prefer. Okay, what is the first step? What is the second step? Awesome.
Apply
yes.
Log to both?
Yes. Apply natural log to both sides, of course, and then?
Differentiate.
How?
Implicit.
Yes. Differentiate implicitly. So please remember, a function raised to another function has absolutely no rule. We cannot apply the chain rule, we cannot apply the power rule, we cannot apply any rule we studied. But what we can apply is something called a 2-step procedure. First, we apply natural log to both sides. And number 2, we differentiate implicitly that equation by applying differentiation to both sides. Awesome. Okay, so now we have a function, arcsine of the square root of tangent 2x. We are asked to find f prime. Before we find f prime, which is here, and that's it. That's all I wanted to say for today. Please tell me how many functions are found when decomposing f of x. So count them, and I'll put a number here. Please.
Is it 3?
So I heard what?
I thought it was
3.
4.
I heard 4. I heard 3. Good. Anyone else?
2.
I heard 2. Anyone else?
5.
Okay, I heard 2 and I heard 5. Okay, so now let's count. First function is arcsine. The second function is the square root. The third function is tangent. The last function is 2x. The other way around, decomposing. 2x is the first one. I have to find a value for 2x. If x is 10, 2 times 10 is 20. Then I apply tangent to it. That's function 2. Then I get a number, and I apply the square root to it. And when I'm done, I apply arcsine to it. So when I decompose, I go from the inner to the outer, but it's the same number of functions as I go from the outer to the inner. Imagine we evaluate when x is 3, 6, tangent 6, the square root of this value, I don't know what tangent 6 is, and then I get a number, and then I apply arcsine to it. 4 functions. Okay, so now, can anyone help with differentiating this? It's okay. Again, it's okay. We are learning. Okay, so can anyone help with this?
1 over the square root of, it'll just be 1 minus tan 2x.
Yes, because we have to square that. Excellent. Good. So we're done with this.
Times
Yes.
1 over 2.
The square root of tangent 2x. Now times tangent 2x but prime
Is that secant tangent?
is secant 2x.
Secant
Secant squared 2x times the innermost
Times-
function prime. Because I of course I always run out of room, I'm going to put it here. And yes, I will simplify these two. I will condense the function by putting secant squared 2x at the top and these two radicals side by side. And that's it. That's correct. Awesome.
Why
Well,
is the 1 minus in with the x on the first differentiated term?
it's arcsine. Arcsine prime is 1 over the square root of 1 minus this squared.
Okay.
Arcsine prime. So we have secant squared 2x. I will put this first, the square root of tangent 2x multiplied by the square root of 1 minus tangent 2x. And this is it. Well done. Thank you. Okay, I hope you're going to review these questions. They're very important, all of them. And now I'm ready for anything you want to bring to the table, anything.
So my first question from WebAssign was in 3.5. It's number 4, and I'm just gonna paste it in the chat for translation.
So we have, is it x cubed?
Yes.
So you said,
x cubed and y squared.
okay, x cubed. And then in parentheses, x plus y squared.
No, x plus y equals y squared.
So,
in parentheses, 6x minus y.
and squared, and then 6x minus y. Okay. Well, what are we asked to do? Differentiate
Implicitly, yep.
So find dy over dx?
Mhm.
Okay, good. So I have x to the 4th plus x to the 3rd y equals 6xy squared minus y to the 3rd. And now I'm ready to differentiate implicitly. So this is 4x cubed plus, this is the product rule, 3x squared y plus x cubed dy over dx. Product rule again, 6y squared plus 6x times 2 times y times dy over dx. And then minus 3y squared dy over dx.
Could
So-
you pause here real quick? If you don't mind?
Say that again.
Could you pause here real quick
Yes. So 4x to the third, 3x squared y plus x cubed dy over dx. First function prime is 6, y squared plus 6x times 2 times y times dy over dx minus 3y squared dy over dx. Now, we have the variable in 3 different terms. They all have to be on one side. So these two are here, but this one has to be brought to the other side, and this has to go to the left. So 4x cubed plus 3x squared y minus 6y squared equals, I'm going to put this one first, 12xy, but minus x cubed and minus 3y squared, and then dy over dx. So I copied these two, and I brought this one from right to left. From these 3 terms, I factor out dy over dx. I put the first one here, 6 times 2 times xy. And then this was positive, but I had to move it to the other side, so it becomes negative x cubed. And this was already negative, and it's on the right-hand side. So finally, I have dy over dx as the ratio of this over this. Any questions on this? Did you find the error, or did you get the answer to the question that you had, or?
Yeah, in at least two, I was looking at my work in at least 2 different spots. I just moved to the next step with the wrong numbers. Like
Okay.
left the square off of one of the numbers, that stuff.
That's
Thank you.
why we are here, to correct these. Perfect. Anyone other questions? Anyone? Anything?
Yes, I had a couple of questions from 3.6.
Yes, 1 second. Anyone has other questions on this problem, or we move on to 3.6? Other questions on this? Okay, I'm ready for 3.6.
Okay, so the first one is f of x is equal to sine.
Which
of
number is this for everyone to know?
2.
Okay, very good. I'm ready.
Sine of 5 natural log of x.
Like this?
And then there's a parentheses and with the x as well.
Okay.
Yeah, and that's it.
So we have f of x. Is this f of x?
Yeah, it's f of x.
Good. And we are asked to find f prime?
Yes.
Good. So first of all, we have to differentiate sine, and we get cosine of 5 natural log x. And now we have to differentiate the inner function, which is 5 times 1 over x. I will rearrange it a little bit as 5 over x cosine 5 natural log x. Is this okay?
Yes.
Any step that is not clear here, or something needs more explaining?
Because actually no, yeah, that's fine.
Okay.
The second one was
Yes.
f of x is equal to natural
Which number
log
for everyone to know? Which number was this?
3.
Okay, very good.
Natural log of 9 sine squared of x.
Was it like this?
Yes.
So
And then
natural
the
log of
parentheses.
quantity 9 sine squared x. Is this okay?
Yes.
Perfect. That's it. But does it? Do we have anything else?
No, that's it.
Perfect. So we want to find f prime. So first we differentiate natural log, so which will be 1 over this. But now I have to differentiate 9 sine squared x. Bring down the power. Subtract 1 from the power times the inner function prime, which is cosine x. At this point, I have to simplify. Let me use a different color. I will simplify a sign, one from the top, one from the denominator. I will simplify a 9, one from the top and one from the denominator. And what I have left is a 2 and cosine over sine. 2 cosine over sine, which is 2 cotangent x. Is this okay?
Yes, that's fine.
Every step clear?
Yes.
Do I need to repeat any of this for you or anyone else? Anything?
I'm good.
Okay, perfect.
And then, sorry, I had one more in that section,
That's fine.
which was it was number 4, and it's y is equal to 4 over natural log of x.
And we want to differentiate this.
Yes.
Perfect. This is what I recommend. Y equals 4 natural log x to negative 1. Because it's only one term, and because I don't have x in the numerator. I would not. That's my habit. You can say, no, I want to use the quotient rule. Fine. Legitimate, correct, everything. I don't. When I don't have a variable at the top, why would I bother with the difference quotient, with the quotient rule? I don't. I prefer this. But you can use the quotient rule. So y equals, I bring down the power, negative 4, natural log x to negative 2, subtract 1 from the power, times the inner function prime. And then I can rewrite it as 4x natural log x, everything squared. I can always go back to a fraction in a blink. You will get the exact same answer with a quotient rule. But you have to be very careful because when you differentiate 4, make sure you get 0. If you don't get 0, you mess up the problem. So that's why I don't consider it useful. If there is no variable at the top, it's just a constant, I will always do this. Good, very good questions. Anything else?
I had a question.
Yes.
The derivatives assessment.
Yes?
It was numbered. It's,
We have to find a similar question with that. I can't solve that particular one.
okay, that's fine. Well, I'll give you the original problem and maybe you can
Yes.
look up some.
Yes, I'm ready.
So in the numerator is 4w squared minus 8w plus 6. And then in the denominator is square root w.
That's it?
Yep.
So the only hint that I can give here is to simplify the function first. Because the denominator is or has
A square root.
no. Because the denominator is or has only
One term.
exactly. We showed these examples in class, and let me choose another.